Welcome to Precalculus Concept 24a, trig functions and the unit circle. We're going to use the unit circle to help us define trig functions of real numbers. So that sounds really scary. I don't know about how it sounds to you, but it can sound scary for some students. So what I'm going to do is I'm going to back up and go back in time and talk to you about geometry for just a second for this box, which I'm calling the box 0. You remember from geometry that every right triangle has 3 sides. Okay, the reason I know this is a right triangle is because I have my indicated little box for the right triangle. And I am talking about this specific angle over here in the bottom left-hand corner, which I'm calling theta. So I wonder if you remember the 3 sides of these names of these triangles. The side of the triangle that was opposite to the angle, so this side over here, this is called the opposite side. Hopefully this looks familiar to you. The side of the triangle that actually touches the angle is called the adjacent side. And then, of course, the side that is always opposite the right angle is called the hypotenuse. I just gave it away there. So we have these 3 sides for the names of the sides of a triangle, and we use these sides to talk about trig functions because trig functions are nothing more than the ratios. So I'm going to remind you of all of the 6 trig functions, or maybe the 3 trig functions that you learned in geometry, hopefully. The sine of angle theta is the definition. The sine is the opposite over the hypotenuse. It is the opposite side over the hypotenuse side. Okay? The cosine of my angle theta is equal to the adjacent side divided by the hypotenuse. And again, this should be familiar to you. And then, of course, we have the tangent of my angle theta is equal to the opposite side divided by the adjacent side. So really, you guys, trig functions are nothing more than ratios of triangles. That's all they are. Now, there are also 3 other trig functions. There is cotangent of theta. And cotangent is the reciprocal to tangent. So instead of having opposite over adjacent, we would have adjacent over opposite. Okay, the secant is the reciprocal of cosine. So instead of having the adjacent over the hypotenuse, we would have the hypotenuse over the adjacent. And cosecant is the reciprocal to the sine. So instead of having opposite over hypotenuse, the reciprocal would be hypotenuse over opposite. So this is where our talk begins. And I'm not sure if you were familiar with these or not, but in case you weren't, there's a little 2.5-minute video lesson as to the ratio of the sides of a right triangle, and this is where our study of the unit circle is going to begin. Okay, so here's where our unit circle begins with the 6 trig functions. So a unit circle is nothing more than a circle centered at the origin that has a radius of 1. That's it. That's all it really is. Okay, it's centered at the origin, which is here, has a radius of 1. So that means that this distance right here is worth 1, and this distance right here is worth 1 since they're both radius. Okay? Now, consider this. What if I were to make a right triangle inside of my unit circle? And I would label this triangle, since this point over here is some x coordinate and some y coordinate on the unit circle, that means that if I were to take a look at this triangle here, and I drew this triangle over here a little bit more, okay, I would get this picture. I would have nothing more than a right triangle. This is my angle theta, which is the same angle that would be right here. The hypotenuse has a value of 1 since it's a unit circle. This distance here is what we're calling the x value, so this is worth x. And this distance here is the y value, because that's how tall it is, so we're going to call this y. So notice that I could draw lots of different right triangles inside the unit circle. Well, this is where our knowledge of geometry is really going to be really helpful to us because it's going to define some things for us in terms of the unit circle. So take a look at this. If I was to be interested in the sine of theta, right? Well, I know from geometry that the sine is the opposite over the hypotenuse. So that would be the y value just divided by 1 in this case, since the hypotenuse is worth 1. So look what I've just discovered. I've just discovered that the sine of theta is always going to be worth the y coordinate value on any point on the unit circle. That's really, really helpful. Okay, let's take a look at the cosine, right? The cosine of theta is equal to, remember the adjacent side over the hypotenuse, so that'd be x divided by 1. So therefore, I have now learned that the cosine of theta is tied to every x coordinate on the unit circle. So I have sine theta is worth y, cosine theta is worth x, and I can keep going, can't I? I know that the tangent of any angle theta is the opposite side to the adjacent side, so that's going to be the y over x. Oh, very, very helpful, all right? As long as x is not equal to 0, of course. Okay? Then I can also talk about the cotangent of theta. It's the reciprocal of tangent, so that's just going to be x over y, of course, where y is not equal to 0. I can talk about the secant of theta, and the secant of theta is 1 over the cosine, so that's just going to be 1 over x, wherever x is not equal to 0. And then, of course, finally, I can talk about the cosecant of theta, which is the reciprocal to sine, so that's 1 over y. So this happens where y is not equal to 0. So now I have a new way of talking about every x, y coordinate point in terms of its trig function: sine, cosine, tangent, cotangent, secant, and cosecant. Okay, let me give you an example of how this is going to work. So we're going to use the picture to find all 6 values of the trig functions of theta. Okay, perfect. All you really need to know is that this is the x coordinate and this is the y coordinate. So I'm going to use what I did in box 1 to figure this out, right? So the sine of my angle theta is equal to the y coordinate. So therefore, the sine of theta is just equal to rad 3 over 2. That's it. It's the y coordinate. The cosine of theta is equal to the x coordinate. So therefore, the cosine of theta must be negative 1/2. Okay. The tangent of theta is defined as the y coordinate divided by the x coordinate. So the y coordinate is rad 3 over 2 divided by the x coordinate, which is negative 1/2. If I simplify that fraction, you guys, I would just get negative rad 3. So once I have all these answers, I can easily find the other one. So the cotangent of theta is the x value over the y value. So that's negative 1/2 divided by rad 3 over 2, which is negative 1 over rad 3. If I rationalize the denominator, I get negative rad 3 over 3. Okay. The secant of theta is the reciprocal to cosine, so it's 1 over x. So that's just 1 over negative 1/2, or a value of negative 2. And then finally, the cosecant of theta is equal to 1 over y, which is just 1 over rad 3 over 2, which is 2 divided by rad 3. And then if I rationalize the denominator, I get 2 rad 3 over 3. So as long as you know that the sine value relates to the y coordinate and the cosine value relates to the x coordinate, you can figure out all 6 of the trig functions. Okay, here is a point on the unit circle. Rad 3 over 2, comma 1/2. I want you to use the picture to only define the tangent of theta. Okay, hopefully you got the right answer. The x-coordinate is rad 3 over 2. The y-coordinate is 1/2. Therefore, the tangent is defined as y over x. So I get 1/2 divided by rad 3 over 2. So I get 1 over rad 3. Now, rationalizing the denominator, I multiplied top and bottom by radical 3. So that gives me rad 3 over